Hey guys, welcome to NFX. In this video, I'm going to show you how to create this impact dust in Houdini. So let's jump in Houdini. So as you can see, I have this animated character. This is Hulkbuster, and I have this ground also. This is just a grid. First of all, I'm going to just select this foot part. So I just select this both footpath and just delete it and select it, delete non-selected. After this, I'll take a color node and give this to red color. And here I also take a color node and give this black color. After that, I'll take attribute transfer and I'll transfer this red color on our grid. So I just transfer only color attribute and it's not coming. Okay, I have to just switch the inputs. So we can we can switch the manually or we can press shift R for switch our inputs. So now our color is transferred on our grid and but it's not transferred properly because we don't have enough subdivision on our grid. So I'll take here subdivide node and increase the depth, maybe 3. uh, it's coming now, maybe 4. Oh, this is okay. No, it's not fine. The color radius is too much, so we have to reduce the area of our color. So we can reduce this distance threshold, maybe 0.2 or 0.25. Maybe 0.3 is okay. Mm, I think this is fine. Now I'll take a blast node. Now I'll take a delete node and an operation. I select delete expression and type here add cd is greater than zero point 0.1 and select this delete non-selected. So I have only this red part. So if I just turn our viewport light color, so we have the mesh only in our red part. So we will create our dust from this red part. So first of all, we will set our normals. So I'll take here a normal node, normal, yeah, and select here points, and I'll take here point node, and I'll take now a point warp. So connect this point node here in the second input. In this point node, I'll take a normal, and the back expression should be Sperify P, or maybe Sperify N. Yes, yeah, this is good. So we will mix the both normals directions. So our all normals is pointing outward. Now I'll go to the point warp, and here I'll take import point attribute, and I'll take mix node, and I'll connect this normal in the first input, and this import point I'll choose the second input, which is this point node, and in the attribute I'll take normal, which is L, and connect this in the second input, and I'll connect this into the seed N, and I'll just promote this bias. So we can now adjust our normals directions. So I'll take this one. So I'll take this position, or maybe point 0.8. Point 0.8 should be okay. And now I'll take point triangle, and here I'll just convert this normal into velocity. So I'll type here add v is equal to add n, and add v multiply is equal to ch, and type here some name, maybe mult multiply, and close our code and just create this channel. So here the first expression I convert the normal into velocity, and the second one is for velocity multiplier. So if I turn on this velocity guide, we can't see in the viewport because our multiplier is 0. So if I increase this, we can see our velocity on the viewport. If I increase this more, so this is our velocity. Now maybe here I'll take a point warp. So I'll just turn on this normal, and here I'll take a turbulence noise, and I'll take a multiplier node and multiply our normals, connect our normal to first input, position to position, and turbulence in the second input, and connect it in the normal. So we got some randomness in our normals. So we have the variation in our normals. So we can set this frequency a little bit and reduce this roughness. Not this. We can change the noise type, maybe, or default is okay. We can set it according to our job requirement. So I'll just take the original one, alligator noise, and increase this amplitude. And I'll promote the all parameters outside create input parameters, so we can adjust all values outside the node. So here our velocity is also randomized, and now I'll take pyro source. Now I'll take point velocity, and here I'll take. So by default is coming like this. So I'll choose here keep incoming, and in the curl noise I'll just turn on this add curl noise and increase this scale little bit, and I'll reduce this pulse size by 0.3, so we get this animated velocity. And now I'll take pyro source, I'll just change the mode surface scatter, so we can adjust the points. We can increase this count, maybe 0.05 or 0.03, maybe a little more, 0.02. And now I'll take attribute noise and take a volume rasterizer attribute, and here I'll just create one attribute which is density, and in the noise I'll take here density, and operation should be range value should be minimum maximum. I can just turn on this visualization and reduce this minimum value, maybe minus 0.1 and 1.5. and I can reduce this element size little bit, maybe point 1 should be okay right now. Yeah, we can reduce this more little bit. And I think I should reduce this value element size and reduce this minimum value also. I think it's fine. So we have this noise pattern here in our source, and in this volume rasterizers I'll take density here also, and maybe I have to create here one channel also named velocity, and I have to add this velocity here and here also. Maybe we don't need it here. Maybe we have to reduce this voxel size and add our velocity here also. And now I'll take Pyro Solver and it's not coming. Just reset this cache and play it. It's not working. Our source is generating, but our simulation is not working. So what I did here, I just add only one attribute density here in the Pyro source, and here I also add only density in the attribute noise, and in the volume vectorizer I add here the velocity and turn on this velocity blur so we can get this streaky type source. We can adjust this shutter so we can get more or less streaks in our source. So this will give us the feel of impact in our simulation. So just turn this on and let's play. As you can see, our dust is coming. Now we can add our collision. So I'll take this grid and take a volume, extrude volume, so we can get this thickness. And now I'll take VDB from polygon and reduce this voxel size 0.05 and connect this here in the collision input, and let's play. And now, and I also take this character leg for collision. So I'll just select this leg part only. So I pick this lasso tool and select the leg part only. So I select this, select both leg and delete it. Just separate this delete node here and turn on this delete non-selected. And now I'll take polyfill node and it's not working. So because maybe, so I'll just delete this node only. Just reselect this leg part, one leg part, and now I'll take polyfill node, polyfill, and still it's not working. If I take this, if I take this edge and select this edge loop, so yes, because if I take here fuse node, uh, fuse node here, and it should work. Yes, it is working. So without the fuse node, we can't select our loop. So I think it should work now. So I'll select the other leg also. Again, I'll just select this other leg and enter. Yes, it's working. Now I'll take here VDB from polygon and reduce the voxel size 0.05 or maybe 3, and just take a merge node and combine this ground and our character leg. And now we can merge this our simulation and our character to see how it's looking with our character. And let's make a preview. I just forgot to tell you, I add some details here. I just turn on the disturbance and set the disturbance 1 and block size is zero point 0.2. And I also turn on this turbulence and turbulence, set the turbulence zero point 0.5 and soil size is also zero point 0.5. And the threshold by default here is set temperature, but I use density because our turbulence work better with the density in our case. And here I also use density. And now I'll take null here Take Pyrobic volume. Let's play a little frame. So we can add a color in our dust. So it's working in our character also. Just remove this here. And just give it a light yellowish color. So this is our dust setup. Now we can render our dust. Hope you will found this useful. Thanks for watching.